Hello my dear students, I warmly welcome you to CR's digital classes. In this video, we are going to see the introduction of our topic, areas and volumes. So in this video, we are going to deal with the two-dimensional figures. So let us see. So basically these two-dimensional figures are somewhat like this. So first of all, our first figure is square. So the area of a square. So the area of a square is what? A square. And the perimeter of a square is 4a. And in our questions they will also ask what is the diagonal of a square. What is the diagonal of a square? So we know that the diagonal of a square is nothing but root 2a. So the diagonal of a square is what? Root 2a. In the same way, the area of a rectangle is what? Length into breadth. So here the longer side is called as length and the shorter side is called as breadth. So the area of a rectangle is length multiplied by breadth, and the perimeter of a rectangle is 2 times of L plus B. Now, if you want to find the diagonal of a rectangle, then we know that the diagonal of a rectangle D is equals to under root of L square plus B square. Okay. Now coming to the triangle. So the area of a triangle is half base into height, where B is the base of the triangle and H is the height of the triangle. H is what? Height of the triangle, and perimeter of a triangle is sum of all the 3 sides. Okay. Now coming to next question. These questions are frequently asked in our exam. So these are called as garden path or road questions. For suppose a field is here, a rectangular field is like this, and around this particular field we have laid a path. So here the path is outside, and here this is the rectangular field which is marked in red color. So the red color is our rectangular field, and a path is laid inside this rectangular field. Inside this rectangular field we have laid a path. Now what we have to find? We have to find the areas of this path. So for solving this type of questions, for knowing the areas of these paths, we have certain formulas. What are those? So for finding the outside path, so if the pavement or the path is laid outside the rectangle or a square, then we should follow the formula which says length plus breadth plus 2w, where w is the width of the path multiplied by 2w. Okay, this is outside path if the pavement or the path is outside. Now if suppose the path is on the inside, what we have to do? We have to apply this formula which says length plus breadth minus 2 times of width into 2w, where w is the width of that particular path. Okay. Now coming to one question or two questions in this topic. Now a path of uniform width 5 meters. So here the width is given as 5 and runs along the outside of a rectangular field. So here the path is running outside the rectangular field of length. The length of this field is 40 meters and the breadth of that particular field is 35 meters. So let us apply the formula. So outside path is equals to length plus breadth plus 2w into 2w. So here the length value is 40 and breadth value is 35 plus 2 into 5. 2 into 5 is 10. In the same way here 2w is 10. So 40 plus 35 is 75. 75 plus 10 is 85. So 85 multiplied by 10, so 850. So the area of that particular path is 850 centimeter square or meter square. So here our answer is 850 meters. So coming to the next question, which says a path of uniform width 8 meters runs around inside of a rectangular field. So first suppose a rectangular field is like this. Okay, a path is running inside of this. So this is the path. This one is the path. Okay. Now we have to find the area of this particular region. Okay. So whenever our inside path is laid, we know the formula for the inside path, which is inside is equals to length plus breadth minus 2w into 2w. Here the length is given as 34 meters, breadth is given as 22 meters, and width is given as how many meters? 8 meters. Length is 34 plus breadth is 22 minus 2 into 8 multiplied by 2 into 8. Okay, so 34 plus 22 is 56. 56 minus 8 2s are 16 multiplied by 16. 56 minus 16 is what? 40. 40 multiplied by 16 is 16 for the 64. So the area of that particular pavement or the path is 640 meters square. 640 meters square. Now coming to the next formulas, which are right angle triangle. The volume of a right angle. So the area of a right angle triangle is half base into height, and perimeter is base plus height plus h. H is the hypotenuse. So hypotenuse of that particular right angle triangle. How can we find the hypotenuse of a right angle triangle? We know that from childhood we are learning this formula, which says AB square plus AC square is equals to BC square. So AB square plus BC square. AB square plus BC square is AC square, where AC is the hypotenuse, or A square plus B square is equals to C square, which is a Pythagoras theorem. So in this formula, in this way we can find the hypotenuse of a right angle triangle. Now coming to the equilateral triangle. The area of an equilateral triangle is nothing but root 3 by 4 A square, and the perimeter is 3A. So perimeter is what? 3A, and this is an important formula. So finding the area of a scalar triangle. Area of a scalar triangle is nothing but under root of, so here the scalar triangle area is nothing but under root of S into S minus A into S minus B into S minus C, where S is equals to semi perimeter, A plus B plus C divided by 2. So S is the semi perimeter, where A, B, C divided by 2 is the semi perimeter. Now coming to the next formula, which is isosceles triangle. Isosceles triangle is nothing but a triangle in which two sides are equal. So let us say this is A and this is also A, then this side is B. So if we are having a base and height in our isosceles triangle, we can apply this formula, which is half into base into height. So area of a isosceles triangle is also half base height, where base and height are provided. If base and height are not provided, but equal and unequal sides are provided, then this formula should be used, where A is equals to equal side and B is equals to unequal side. B is unequal side. So then the area will become B by 4 into 4 times of under root of 4A square minus B square, and the perimeter is 2A plus B. Okay. Now coming to the next formulas, which are parallelogram. The area of a parallelogram is base into height. So a parallelogram is nothing but where both the sides are parallel and equal. So if this is B, this is also B, and this is A, this is also A. So the area is nothing but base multiplied by height. Base multiplied by height, and the perimeter is 2 times of A plus B. In the same way, the area of a trapezium. Trapezium is nothing but like this. So you should remember this formula. Let us say this side is A and this side is B. This side may be C or D. Okay? This side is C and this side is D. Then the area of that particular trapezium is nothing but half base, half height multiplied by A plus B. Half into height into A plus B. This is not accurate. Okay, but the perimeter is accurate. A plus B plus C. So the area is what? 1 by 2 H times of A plus B, where A is the upper one and the B is the below one. Okay. Now coming to the volume, area of a rhombus. Area of a rhombus is nothing but half D1 D2, where D1 and D2 are the diagonals of that rhombus, and perimeter is nothing but 4A. In this rhombus questions, in this rhombus formula, they will ask to find the side of a rhombus after giving the diagonals. How can we find? So for suppose this length, this total length is D1. So if that particular total length is D1, then this length is what? This length is D1 by 2. Then this particular length is nothing but D2 by 2. So d2 by 2. And in a rhombus, both of the diagonals bisect each other. So a 90-degree angle will be formed. So after seeing this particular triangle, I can say that this is a right angle triangle, and using this right angle triangle, I can apply the Pythagoras theorem and find the value of A. So then the value of A will be found using the Pythagoras theorem. Okay. Now, coming to the next formula, which is circle. The area of a circle is pi r square, and the circumference of a circle is nothing but 2 pi r. Circumference of a circle is 2 pi r. So let us solve some questions in this circle's formula. So in our question saying that find the distance traveled by a wheel in 1 minute. So a wheel is traveling certain distance in 1 minute. So a wheel is nothing but a circle. Okay, a circle. So if a wheel is traveling certain distance, first suppose if a wheel is starting like this and moving, so it is moving, then one rotation will be completed. And this length is nothing but this length. So it has started moving from this point, and after moving till this, it has completed one revolution. This revolution is nothing but the circumference of the circle. This is nothing but what? Circumference. So it has covered, in one rotation, it has covered how much distance? It has covered 2 pi r distance. So in one rotation, it is covering 2 pi r distance. So here the radius of the circle is given. So radius is 21, and in 1 minute the circle rotates 8 times. So in 1 minute there are how many rotations? 8 rotations, and we know that one rotation is nothing but 2 pi r. So 8 into circumference is 2 pi r. So after solving this, I can say that it has traveled this distance. So the distance traveled is equals to 8 times of circumference, because it is doing 8 rotations in 1 minute. So for one rotation, it is traveling a distance of 2 pi r. So 8 into 2 into the value of pi is 22 by 7. The value of r is what? 21. Okay. So 7 3s are 21. 8 2s are 16. 16 into 22 into 3. 16 3s are 48. 48 multiplied by 22. So 48 2s is 96. So 4 and 5, 1054. So the distance covered is 1054 centimeters. So because the radius is 21 centimeters, then the distance covered is 1054 centimeters. Okay. Now coming to the next question, which says a circular pavement is constructed around a ground if the radius of the ground is 21 centimeters. So I have a ground like this. The radius of this ground is what? 21 centimeters, and I am constructing 3 meters wide path around it. So I am constructing a circular path around it, and the width of this path is how much? 3 meters. And the width of this path is how much? 3 meters. Now I have to find the area of this pavement. I have to find what? The area of this particular region which I am drawing. So in order to find this area, what I have to do? I have to subtract the area of bigger circle with the area of smaller circle. So to solve this, I have to subtract the bigger circle area minus smaller circle area. So the bigger circle area, so r1 is the bigger radius and r2 is the smaller radius. How can I find the bigger radius? I know the smaller radius is 21. If I want to find the bigger radius, so the bigger radius is nothing but from here to here, or I can say this is from here to here, it is 21, and this small value, this value is how much? This value is 3. So the bigger radius is 21 plus 3. So I can say that the bigger radius r1, let r1 be the bigger radius, which is 21 plus 3, which becomes 24, and r2 be the smaller radius. The smaller radius is 20. So what I have to do now? I have to subtract the smaller radius from bigger radius. So let us see. So pi times of r1 square minus pi times of r2 square. I have already given the area formula here. So after taking common pi, so r1 is nothing but 24 because it is bigger. 24 square minus 21 square. So this is in the format of a square minus b square. A square minus b square can be written as a plus b into a minus b. So pi times of 24 plus 21 multiplied by 24 minus 21. So the value of pi is constant. Let us take it as pi itself. So 24 plus 21 is what? 45. 45 multiplied by 3. So 45 3s are 5 3s are 15. 4 3s 12. 135. So the area of that particular pavement is 135 pi meters. Okay, 135 pi meters. So here the width of the pavement is 3 meters, not 3 centimeters. Okay. So first of all, the first three-dimensional geometric shape is cube. So a cube. The volume of a cube in 3 dimension, there is no area. We will be having volumes. So volume of a cube is what? A cube. Volume of a cube is a cube. And curved surface area. Curved surface area of a cube is 4a square. The curved surface area is also called as lateral surface area. Curved surface area is also called as what? Lateral surface area. So lateral surface area is 4a square, and the total surface area, TSA, total surface area is 6a square. Total surface area is what? 6a square. Now in this particular question, they will ask what is the longest pole that can be fixed in a cube. So they will ask what is the longest pole that can be fixed in a cube. So longest pole is nothing but diagonal of a cube. So they will not ask as diagonal because it is inappropriate to ask as diagonal. So they will ask what is the longest pole. So we know that in a square the formula for diagonal is root 2. In the same way, the longest pole that can be fixed in a cube is root 3. As square is a two-dimensional figure, it is getting the value as root 2a, and cube is a three-dimensional figure, so it is getting the value as root 3a. So the longest pole that can be fixed in a cube is root 3a. Okay. Now coming to the next. So let us solve a question on this. If the curved surface area of a cube is 196 centimeters, the curved surface area of a cube is what? 4a square. This is given as 196 centimeter. Okay, centimeter square. It should be centimeter square. Areas are always centimeter square, and volume should be centimeter or meter cube. So 196 centimeter. So 4 for the 16, 4 9 is 36. Then the a square is, if a square is 49, then the value of a is 7. So the value of a is what? 7. But in this question, we should find the total surface area. The total surface area of a cube is 6a square. So 6 into a square is 49. So 6 9s are 54. 6 4s are 24. 294 centimeters square. So the total surface area is 294 centimeters square. Now coming to the next question. Next formula, which is cuboid. In cuboid, the volume is length multiplied by breadth multiplied by height. We know that a rectangular is a two-dimensional shape. Rectangular is a two-dimensional shape, and the three dimension of this rectangle is cuboid. Three dimension of rectangle is cuboid, and the curved surface area of a cuboid is nothing but 2h into L plus B. 2 times of height multiplied by L plus B, and the total surface area is what? 2 times of LB plus BH plus HL. LB plus BH plus HL. And in this question also, in this particular formula also, they will ask what is the longest pole that can be fixed in a cuboid. So they can also ask what is the longest pole. So we know the diagonal of a rectangle is under root of L square plus B square. So in rectangle we have only length and breadth, but in a cuboid we are having three values, which are length, breadth and height. So the longest pole will become what? Longest pole is nothing but under root of L square plus B square plus H square. So the longest pole is under root of L square plus B square plus H square. Okay. Now coming to the next one, which is find the height of a cuboid with a length 14 centimeters and breadth is 13 centimeters. Given the length of a cuboid is 14, breadth is 13, and the curved surface area CSA is given, CSE is given as 648. Curved surface area is given as 648. We know the curved surface area of a cuboid is 2 times of h into L plus B is 648. Let us substitute the values here. 2h into L is 14 plus 13 is equals to 648. So 2 1s are 2, 2 3s are 6, 2 2s are 4, 2 4s are 8. So h multiplied by 27. 14 and 13 is 27. 324. The value of h is equals to 324 divided by 27. So 27 ones are 27. 27 twos are 54. So the height is nothing but 12 centimeters. Okay. Now coming to the next formulas, which is a cylinder. So the volume of a cylinder is nothing but pi r square h, and curved surface area of a cylinder is 2 pi r h, and total surface area of a cylinder is 2 pi r h plus 2 pi r square. From this I can take common as 2 pi r, then I am left with r plus h. So the total surface area of a cylinder is nothing but 2 pi r into r plus h. Now in this particular question also they can ask what is the longest pole that can be fixed in a cylinder. So the longest pole formula is nothing but, this is the radius of the cylinder and this is also radius of the cylinder. The longest pole that can be fit is this one. So this is the longest pole. Now this is what the height. So by using Pythagoras theorem I can find the longest pole. So longest pole area, so let us take that as d, that is equals to, d is nothing but h square plus 2 times of r whole square. So the longest pole, this is the formula of a longest pole in a cylinder. Okay. Now let us solve a question on this. Find the curved surface area of a cylinder where area of a base is 154. We should find what? Curved surface area. Curved surface area of a cylinder is nothing but 2 pi r h. We should find this particular answer. Now here in this question he has given the area of base. So in a cylinder the base is what? The base is nothing but a circle. In this question he has given the area of circle. We know that the area of a circle is pi r square. So pi r square is given as 144. Then r square is nothing but 144 into 1 by pi. The value of pi is 22 by 7. Then r square is equals to 144 into 1 by 5 is 7 upon 22. 22 sevens are 154. So the radius is nothing but 7. So the radius of that particular cylinder or that particular circle is 7 centimeters, and he has given the height. Height is what? 20. What should we want to find? We have to find the curved surface area of cylinder. So CSA is nothing but 2 pi RH. 2 pi RH. So 2 into pi is 22 upon 7. Radius is 7. Height is 20. So 7 gets cancelled. 22 into 2 is 44. 44 multiplied by 20 is 880. So our answer is 880 centimeter square. So the curved surface area is 880 centimeters square. Now coming to the next formula, which is the cone. So volume of a cone is nothing but 1 by 3 pi r square h, and the curved surface area is pi r l, where L can be found out through by using Pythagoras theorem. L is nothing but r square plus h square. L is the slant height. L is called as the slant height of a cone, and L can be found out through using r square under root of r square plus h square, and the total surface area of a cone is pi r into r plus L. So let us solve a question on this. So the ratio of volumes of two cones is 2:3. So there are two cones V1 and V2. The volumes of these cones is 2:3. The volume is given as 2:3, and the ratio of the radii is R1 ratio R2 is given as 1:2. R1 ratio R2 is given as 1:2. Now what I have to find? I have to find the ratio of their heights. I have to find what? Ratio of their heights. So we know that volume of cone 1, volume of a cone 2. Volume of a cone is nothing but 1 by 3 pi R1 square H1, because this is cone 1 and this is cone 2. 1 by 3 pi R2 square H2. This volume ratio is given as 2 by 3. This volume ratio is given as what? 2 upon 3. Now 1 by 3 gets cancelled, pi and pi gets cancelled. The R1 value and R2 values are given here. So let us take R1 as 1 and R2 as 2. So 1 square H1 divided by 2 square H2 is equals to 2 upon 3. So H1 by H2 is equals to 2 by 3 into 4 by 1. So this is 1 by 4, this will become 4 by 1. So 2 by 3, 4 by 1. Then H1 ratio H2 or H1 by H2 is 8 by 3. So H1 ratio H3 is what? 8 ratio 3. Okay. So this is the heights ratio of H1 and H2. Now coming to the next formulas, which are sphere and hemisphere. So the volume of a sphere is 4 by 3 pi r cube, 4 by 3 pi r cube, and the curved surface area and total surface areas of both the sphere is equal. So this is curved surface area and this is also the total surface area. So the curved surface area and total surface area of sphere is same, which is 4 pi r square, 4 pi r square, and the volume of a hemisphere is 2 by 3 pi r cube. The volume of hemisphere is what? 2 by 3, because this is half of the sphere, and the curved surface area of a hemisphere, curved surface of a area of a hemisphere is 2 pi r square. This is the total surface area. The total surface area of a hemisphere is 3 pi r square. So sphere is nothing but a cricket ball. You have seen a cricket ball in your life. So sphere is nothing but a cricket ball, and hemisphere is nothing but when a cricket ball is done half. So it is, if it is cut into half, it is called as a hemisphere. Now, so in our exam, there are being multiple questions asked from this model, which is equal volume model. So let us see what is this equal volume model. So if, for suppose I have a cylinder like this, now this cylinder is of pure metal, so it is made of pure metal. Now what I have done is I have melted this particular cylinder and made them into cones. I have melted this cylinder and made them into some cones. I don't know the value of cones. I have made n cones using this. So I can say that the volume of this particular cylinder is equal to the number of cones, the volume of cones multiplied by how many cones. For suppose if I made 2 cones using this volume of this cylinder, volume of cone, then I can say that this volume of cylinder is equals to, there are 2 cones being made into volume of cone. So these are the equal volume problems. Okay, now let us solve some questions using this. So what is the height of a cylinder that has, we have to find the height of a cylinder that has same volume. So same volume and radius. So the volume of a cylinder and volume of a cylinder and radius of cylinder is equal to the sphere. So here he is saying that volume of cylinder is equals to volume of sphere, and radius is also equal. So let us see. We know the volume of a cylinder. Volume of a cylinder is what? Pi r square h. And volume of a sphere. What is the volume of a sphere? Volume of a sphere is 4 by 3 pi r cube. Okay, 4 by 3 pi r cube. Now the radius of both of them are equal. So the radius is given as 6. Let us substitute. So here pi and pi gets cancelled. So radius is 6. 6 into 6 multiplied by h is equals to 4 by 3 into 6 cube, because radius is here 6 times. So 3 2s are 6. Okay, 3 2s are 6. So 6 and 6 gets cancelled. So height is nothing but 8 centimeters. So height of that particular cylinder is what? 8 centimeters. Okay, now coming to the next question. which says a child reshapes a cone made of clay of height 24 centimeters and radius 6 centimeters. So a cone, the height of that particular cone is what? 24 centimeters and radius is what? 6 centimeters. So he is reshaping this cone into what? He is reshaping this cone into a sphere. So what we have to do, we have to equate the volumes of this cone and volume of this sphere. So volume of a cone is 1 by 3 pi r square h and volume of a sphere is 4 by 3 pi r cube. So pi and pi gets cancelled, 3 and 3 gets cancelled. So r, the value of r is 6 multiplied by 6, h is 24 is equals to 4 into r cube. So 4 6 are 24. So 6 cube is equals to r cube. Then the radius of that particular sphere is what? 6 centimeters. So radius of the sphere is 6 centimeters. Okay. Now coming to the next question, which is a right circular cone of height 20 centimeters and base radius 15 centimeters is melted and cast into smaller cones of equal sizes. So a cone, right circular cone, a bigger cone, a cone is being melted and made into smaller cones. So it is a right circular cone of height 20, it is being made into smaller cones. So these cones are being made. So we don't know how many cones are being made. So I can say that the bigger cone volume, so the volume of bigger cone is equals to n into smaller cone volume, n into smaller cone volume. So let us see here the bigger cone radius, the radius and height. Radius of a bigger cone is 15 and height of that particular bigger cone is 20. This is bigger cone. Now let us see the smaller cone. The radius of the smaller cone, let us say R2, this is H2. R2 is here 1.5 and H2 is 5. So let us equate this. So volume of a cone is nothing but 1 by 3 pi r square h is equals to n into 1 by 3 pi, here r1 h1, this is r2 square h2. So here 1 by 3 gets cancelled, pi and pi gets cancelled. Okay. Now r1 is what? 15 to 15 into h1 is 20, that is equals to n multiplied by r2 is what? 1.5 into 1.5 into 5. Okay. Now I have to find the value of n. N value is equals to 15 into 20 divided by 1.5 into 1.5 into 5. Okay. So 15 divided by 1.5 is 10. 1.5 tens are 15. So 5 4 the 20. So there are how many cones being made? There are total 400 cones being made out of that particular bigger cone. So our answer is 400. Now thank you very much for watching this video.